All right, on these examples, the only thing that we see that's different, and we're going to start with these, well, these three, is that we see these numbers are less than 1. Remember, since these numbers are less than 1 as decimal values, then we're going to be using negative exponents. So, starting with E, well, we got 7, what is that, 7,500 thousandths is what it looks like. And we know the decimal, yeah, that would be a little bigger, that seems better. The decimal is going to go right after the 7, right? Right between the 7 and 5, which is going to make the decimal value in scientific notation 7.5. Of course, it's still multiplied by 10. And yes, this is less than 1. The original standard form number is less than 1, which means the exponent is negative. So I'm putting that negative already into the exponent. I just got to see how many place values are between the decimals. 1, 2, 3, 4. So it ends up being an exponent of negative 4. And this is my final answer, 7.5 times 10 to the power of negative 4. Now, is it possible that you could check this? Yes, there is. But I'm going to wait. I'm going to wait till the third example to talk about that. All right, same thing on this one. Again, we have it written in standard notation. Let's figure out where the decimal goes. Remember, in the ones place value, it should be a non-zero number, so I can't use any of those zeros. But the 4 I can use, so that's where the decimal would go, right after the 4. Which would then make that 4.005. And then, of course, we're going to multiply this by base 10. Once again, that original number is less than 1, so it's going to be a negative exponent. That's a negative there. But how many place values are between the decimals? 1, 2, 3. So I end up with a negative 3 exponent of base 10. And once again, this is our final answer right here. Yeah, do be careful because 0.4005 times 10 to the power of negative 2, it's equivalent, but it's not formal scientific notation. And, I mean, if you've ever seen a math person freak out, it's not pretty. But if you show that to another math teacher, they're going to freak out about that stuff. I'm not as picky, which sometimes I think is a pretty good thing, actually. It shows a lot of zeros. It really shouldn't be a problem. And again, this is kind of the convenience, especially with an extraordinarily small number like this one, of scientific notation. So I'd look at this and I'd say, look, the decimal has to go between the 9 and 2 right here, right? Which is going to make that 9.2 times 10 to some power, right? Because we're changing this into scientific notation. And we see the two decimals, where it was originally and where we need it to be placed for scientific notation. Now, the number originally was less than 1, so I know the exponent's negative, just like the previous one. But the value of that negative is how many place values are between the decimals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that exponent becomes 10, but negative 10. And so this is that value in scientific notation. All right, so there's those three. And yeah, you can write them in these boxes if you'd like, but whatever. It's the same answer. Let's get to these three. 4.2 times 10 to the power of negative 8. All right. Well, I'm going to rewrite just the decimal, 4.2. Now, remember, if you have a negative exponent, this tells us that we're going to move the decimal to the left. How many times? 8 times, right there, right? So I'm going to move it to the left 8 times. I'm going to need more space on that 4.2 actually, so I'm going to put it over here. That's better. All right, so 8 times to the left. 1, 2, 3, 4, 5, 6, 7, 8. Perhaps I should have given myself more space. Now, there's some empty place values now, which if you have empty place values, just put zeros in there. So what is that? 7 zeros right there. So I end up with 0.123, 4, 5, 6, 7 zeros, and then the 4, 2. And this now is in standard form. So this also means if we saw a positive exponent, just like we talked about in that previous slide, is you'd be moving the decimal to the right. Of course, it won't show the positive sign either. On this one, once again, the exponent's negative, so we're going to move the decimal to the left, particularly 7 times. So I'm going to write 8.12, the decimal value from scientific notation. Then I'll show the movement of the decimal to the left 7 times. There's one place value, 2, 3, 4, 5, 6, 7. So that's where the decimal will be. Any empty place values become zeros. Bam. So this ends up being 0. How many zeros is that? 1, 2, 3, 4, 5, 6 zeros, 8, 1, 2. And now this is in scientific notation. Sorry, that's standard notation, my bad. All right, C is going to work the same way. Let's write the decimal value here, 7.625. And again, this is a negative exponent, so we're going to be moving the decimal to the left. And once again, 3 times, right there. So let's take that decimal, move it to the left. 1, 2, 3 place values, there it is. Any empty place values become zeros. I like to show that 0 in front just because it's pretty. I should have given myself more space though. But this ends up being 0.007625. And there it is, standard form of that original scientific notation number. Now something else I want you to realize on these, and we've said this before about mathematics, particularly with fractions, we emphasize it in fractions, but scientific notation is a way to show a number just in a different format. So we're not changing the value of these numbers, all we're doing is changing the way they look, that's all. So the more we get used to this, the more we can communicate these in equivalent ways, but it may sound different, okay? But it is still the same.